recording. Jolly good. Right. Well, for those of you that don't know us, we are the Informa Telecoms Academy, and just bear with me 1 second. Yeah, so we're effectively we're part of the larger organisation Informa, so we're the Informa Telecoms Academy. And we do a lot of training like this. We do training online. We do classroom-based training. We've got distance learning or correspondence type training, and more or less what we do kind of breaks down into three different schools as we call them. So we've got the School of Telecoms Management. So perhaps some of the less technical topics would be covered in there, things like management, commercial aspects, marketing, some financial stuff. Um, the part which I probably do more work for than anything else is the School of Advanced Communication. So of course this is mostly to do with technology. So it's LTE, it's 5G, LTE public safety, and so on. So in some cases quite sort of in-depth engineering type training. A lot of what we do as well is actually provided on a distance learning or a correspondence basis as well, and we've got a number of programs that we offer on that basis. And some of the programs we do, particularly the distance learning and some of the telecoms management training that we do, we've actually got an arrangement with Derby University. So some of our programs, if we put them together in the right way, are actually university accredited by Derby University as well. If you want to know more about what we do, then of course there's some links there, telecomsacademy.com, and I'll put this slide up at the end as well in case you need any contact details. Now we work alongside as well an organisation called Ovum. They have a resource online called the Knowledge Centre. Yeah, we're in and out of that database all the time, pulling out latest industry trends and so on. It's an extremely useful resource for us as training companies, and a lot of the work that the analysts do actually come through in a lot of the training that we do as well. So if you're interested in sort of on the market side, should we say, the worldwide trends, then that Ovum have a range of sort of products and services that they can offer as well. So. Well, let's get on to the topic that we're going to talk about. About 30 minutes or so. I think this is the only time we that we allow for this. So I think this picture is fairly clear. I think everybody knows this, and it seems these days whenever I do one of these webinars, it's almost this is the topic that we start it off with. So of course we know there's a demand for data, and it continues to rise. But I think the interesting thing is well, it says the second bullet point: increasing number of high capacity applications. I mean, that really is what's driving the data trend. I think as well, though, I mean, because we're saying high capacity applications here, and almost certainly we mean things like video, social networking, file sharing, P2P, that kind of stuff. But as well, when we talk about increasing the capacity of a network, really this means two things. It means, sure, we can increase the data rate, the data capacity to a single device, so you can enjoy your 4K video without buffering. But one of the other trends is really pictured here, this sort of number of connected devices. Well, it's going to be in the X billions of devices in the sort of relatively near future. So whilst a lot of these connected devices, and here we're talking about the Internet of Things, machine to machine, machine type communication, now those devices themselves are not necessarily running high capacity applications individually, like smart meters, utility connections, that kind of thing. But it's a sheer volume of things that might be connected to the network, really, which results in the network having to carry high capacity. So high capacity also means being able to connect, hundreds of millions of things to a single network. And how do we prepare the network for these kind of services and applications? One of the ways of thinking about this is really that the radio technologies are, that we require greater efficiency to do that. So this will be through the use of, clever antenna techniques, finding more spectrum, those kind of things. And in fact, when you look at the evolution of our current mobile technologies, then in fact a lot of what's going on as far as the radio access network is concerned, in fact, is seeking out greater and greater efficiencies through higher order modulation, as I say, fancy antenna techniques and so on. But I mean, we're familiar with the timeline, 1G, 2G, 3G, we're kind of familiar with that process, but it's interesting to start looking at it from the point of view of where 4G starts, because 4G or LTE really is the start of another evolution. I mean, LTE we know stands for the long-term evolution, but that evolutionary process is now evolving itself. So I'm starting this sort of little timeline here. Well, I suppose to kind of be in line with pretty much what all the operators in the world are doing. I mean, we start the process here at 4G. So LTE is certainly now considered to be part of the 4G technology, but of course we know that was first specified in the release 8 and 9 of the 3GPP specifications. But when you look a little bit more carefully at it, the original LTE was actually part of the IMT 2000 evolution. So this is the 3G part of it, and it defined things like new radio interfaces, better efficiency, higher bandwidths, something like times 5 in improvement in performance, depending on how we configure and deploy the network. The other thing, all IP networks, some efficiencies to be had within the network as well. But I think one of the really important things about LTE in its entirety, so the radio access stuff and also the core network stuff, is it really forms a very flexible foundation on which we can then evolve the technology going into the future. And we see this more and more as we start to look at the more recent evolution. So when we get to LTE Advanced, now strictly speaking, this is kind of where 4G starts, depending on which side you kind of fall on here. But it is part of what we might refer to as the IMT Advanced evolution. And IMT Advanced this is a project from the ITU that really defined what the properties or the performance should be of a 4G network. So once we start talking about LTE Advanced, then for sure we're talking about a 4G system. And it's not really just one technology. Because really what we're doing is we're trying to define many different features which can enhance the performance of the network, both in the radio access, directly on the radio interface, but also extending back into the core network, thinking about the services and the service platforms that we need to support. So there's many different performance enhancing features, and I'll show you a few of those with respect to the specification releases in a moment or two. But of course, it's MIMO, carrier aggregation, relay functions and so on. But really what it does is it further extends the capability for the network to continue to evolve. So on the little sort of graph that you see at the bottom here, then really what we're tracking here is the increase in capacity and the reduction in network latency. So at least in theory, the current LTE network will support somewhere in the region of 100 megabits per second. I mean, give or take, 20 megabits per second, with latencies between sort of 30, 40, 50 milliseconds, something like that. LTE Advanced, because of the work done in the radio access network, of course, will increase the data rate, at least in theory, up to about a gigabit per second, largely through the carrier aggregation and antenna techniques such as MIMO. But some efficiencies in the network also lead to lower latency, so we can get perhaps in the order of 10 millisecond latencies now. Now, the next step, it's quite a big step, really. So once we get to release 13, then now we've got LTE Advanced Pro, okay, and really it's a proper sort of step change in the capabilities and performance of the network. So now we're talking about multiple gigabits per second, and latencies of around about 2 milliseconds or so. Now a lot of that is done through a higher order modulation scheme. So as I'm sure you know that the current versions of LTE that we're running, or for the most part that we're running, have 64 QAM in downlink, 16 QAM in the uplink, and that defines really the efficiency of those up and downlink radio interfaces. But LTE Advanced Pro allows us now to do 256 QAM in the downlink, and in fact support 64 QAM in the uplink. So that's going to give a significant boost to the performance of the radio interface, a significant boost in the efficiency of the radio interface as well. But interestingly, we're also extending the capability of our carrier aggregation processes, whereas currently we're limited to something like 5 radio carriers aggregated together. Then, in fact, when we look at LTE Advanced Pro, maybe we could just, for short, we could just call that 4.5G. Some operators are already doing that in any case. But for this, we can support something like 32 so-called component carriers. I don't think anybody's doing that yet because, combining 32 carriers together it's a pretty complicated thing to do. We need to find spectrum, we need to find radios that can support that. But I think key for a lot of machine type applications, ultra low latency is one of the sort of key features required by many different kinds of, we would call them the connected verticals, the parties, the third parties that we might be providing service to. But something which is started in the earlier releases, but kind of is completed by the time we get to release 13, 14, are things like proximity and group service and group services, particularly important for the public safety community. The police radios, the ambulance radios, that kind of thing. And as well, as part of release 13, 14, we've got some new radio interfaces being designed for machine type communication. So low range, low power, high efficiency radio interfaces for that. So, I mean, a lot of those new radio interfaces are not really about maximum throughput, but more about maximum efficiency, both in terms of power and such like. But the other interesting thing about this is, well, okay, LTE is evolving. Okay, so we go from 4G to 4.5G, LTE Advanced Pro. But the big thing that's on the horizon, and we've already done one of these inset webinars about the 5G, is release 15 and beyond. So this, of course, is related to IMT 2020. Those of you that might have attended that webinar will remember that. But 5G. Well, 5G, again, it's not just a new technology. We're not going to change everything again. At least that's the hope. It won't be ready, of course, until about the year 2020. And there's a lot of different sort of opinions on whether it will be just an evolution of, let's say, release 13, 14. So a nice gradual evolution towards higher performance networks, perhaps with 1 or 2 new radio interfaces being thrown in there. But there's a lot of focus on things like network, like core network. How do we build a core network that can support like 1 billion connections and support billing for 40 different types of machine tap applications and so on. So there's a lot to do with the core network, as well as perhaps higher efficiency new radio interfaces and so on. But I think that this foundation that we're laying with the LTE Advanced, and then the Advanced Pro is a really important foundation. How do we get to 5G? Because I mean, if you're an operator, there's a huge amount of investment that you're putting into this, both in terms of buying new radio licenses. Of course, we know those things are not cheap, but upgrading the network components at the base station. In the core network, the transmission networks, the front haul and the back haul networks, all of those things require sort of constant attention and upgrade. So we really don't want, when we get to 5G, we don't want it to be like flicking a switch and having to redeploy an entirely new network. So if it's a little bit more of a gradual and sort of graceful evolution towards the 5G, I think that's going to be it's a positive thing. But of course, the people who are developing this. This is the ITU, the NGMN, 3GPP, many different parties involved. They understand that we have to protect the investments that we're currently deploying with our LTE Advanced networks and such like. So there's a nice evolution there. I'll give you some statistics toward the end about who's doing LTE Advanced, who's doing LTE Advanced Pro, and so on. I'll throw some of those in at the end. But this is just a little bit more detail on what each of those releases contains, and we can say, well, in our release 10, that's clearly that's where LTE Advanced starts, and this is where we can start to talk about at least some of the basics, things like carrier aggregation, extended MIMO capability, both 8x8 downlink, uplink, 4x4. But we've also got some sort of things like relaying techniques. We've got interference control is a kind of continual theme as we run through all of these different releases. But we've got this sort of enhanced interference coordination function. When we get to release 11, you'll see we've got additional carrier aggregation enhancements in here. That's really just specifying more frequency band or band combinations, as well as then beginning to think a little bit more about how do we do things like interference control and how do we do scheduling when there are multiple radio carrier components as part of a single communication link. Those are some quite complex problems that need to be resolved, both from a signaling perspective, but also from a traffic channel perspective. How do we mitigate elements of or instances of interference that might exist both within the cell and from without the cell as well? We begin to see in release 11 things like, well, okay, we've got machine type communications here, so some specific thought now going into how do we provide perhaps low bitrate, low latency communications for specific machine type applications. So again, this will be the utility meters, sensor arrays, smart networks, smart homes, that kind of thing. And then we get through to release 12. Small cells is in there, more machine type communications, but then we start to see interesting things like proximity services and enhancements to the multicasting, broadcasting, multimedia service. And this is where things get interesting if you have a public safety interest, because in fact the proximity services and the evolved MBMS services really form the foundation of of public safety communications. But there's some other interesting things going on in here as well. Things like LIPA and SIPTO. Really, how can we sort of leverage existing radio layer technologies like Wi-Fi? How can we more efficiently route the information without necessarily having to go right back into the core network? Is there any way of kind of breaking the content out of the network, maybe directly from the radio access network? So we're looking at more efficient routing of perhaps high capacity content that can reduce the cost of running the network effectively. And then we get into release 13, and we see things like sort of license assisted access. So again, how do we make LTE play nicely with things like Wi-Fi? There's a number of products already on the market that can do that, CPE equipment and so on. More enhancements for machine tap communications, and so on. I mean, there's sort of an endless list here. I mean, I would recommend that you visit the 3GPP website for a breakdown of exactly what's in each of the releases. In fact, I think this is where I stole this particular picture from. So it's a constant and ongoing evolution in here, and we're not even talking about release 14, 15 in here, but from release 13 onwards, this is probably where we can start considering the network to be LTE Advanced Pro or Professional from that point onwards. But what I'm going to talk about here really is because. Well, I'm going to talk about carrier aggregation here, not in any kind of highly technical way, but really just to some conceptual issues to talk about. But it's by far the most powerful means to improve the capacity of the network. Okay, because we know that the bandwidth or the capacity of the system is really tied directly to the bandwidth of the radio carriers that we can support. So if you've got a 10 megahertz channel or a 20 megahertz channel, that's the thing that defines the capacity of a cell, and how you use that or reuse that throughout your network will then define the capacity of the network. So I'm hesitating to use the word here easy. Okay, because it's never going to be easy. But shall I just say that the easiest way to increase the capacity of a given connection is to perhaps aggregate these carriers together. So each of the individual carriers here. So the idea here is that if you take this sort of orange tunnel or orange pipe that we got here, that might be, for example, a single release 8 20 megahertz radio carrier. Now, at the moment, as a standalone radio carrier, that has a certain amount of performance that it can provide, and what carrier aggregation allows us to do, in fact, is to use these as what's the phrase? Well, I suppose as an aggregated carrier. We can join them together so that two 20 megahertz channels will basically look like a 40 megahertz channel. So clearly, that's a very sort of brute force effect or way of actually increasing the capacity. So two 20s, you double the capacity, you add another 20, you've got another 30% improvement in the capacity. And for release 8 and 9 at least, we have to place a limit on the numbers. So in fact, there's a maximum of 5 of these 20 megahertz radio carriers that can be aggregated, at least in the earlier releases. So again, release 8, release 9. But that's 100 megahertz of spectrum. If we could find the spectrum, if we could find 5 20 megahertz radio carriers and we could allow them to be aggregated together, I mean that's a ton of spectrum. That's a big radio carrier. So of course this means that we can begin to think about and support much higher data rates. So getting towards like a gigabit per second now, especially when we combine this large amount of spectrum with high order modulation schemes, or even start combining with high order MIMO systems, then things like a gigabit per second or even in excess of a gigabit per second are a little bit more reachable. But I mean, you've got to ask yourself the question when we get to this, when we start talking about, a gigabit per second, and I think I probably stated this in previous webinars and so on. I mean, what are you doing with a gigabit per second? We're not really, I don't think we're suggesting here that we're going to deliver a gigabit per second to a single device. I mean, that doesn't really make any sense. But we come back to this idea of what is capacity. So a gigabit per second now, from an operator perspective, will be within a given radio cell would be the potential to connect not just a few dozens or a few hundreds of devices, but perhaps within a single radio cell, perhaps many thousands of devices could be connected at a low speed, and this will be the utility type, machine type communications and such like in there. So these very, very high numbers that we're talking about, really, it's about how many things can we connect to the network rather than how fast can we make the connection for a few people that might be connected to the network. I mean, I'm sure there will be a few people that will enjoy, 500 megabits per second to their iPad or whatever. But I don't know what applications they will be using. If the application will not function without 500 megabits per second, well, I'm really interested in knowing what that application is. For the time being, at least, if you can give me, say, 10 to 15 megabits per second on a fairly consistent basis, most of the applications that I run on my device, will be perfectly happy with that. So, as I say, it's really about how many things can we connect to the network, by and large. So the idea behind carrier aggregation is that you can take multiple channels that they themselves don't have to be the same bandwidth, and in fact they don't even have to be from the same frequency band. So there's a lot of different definitions here. In fact, well, there are 3 definitions here. Of contiguous intra-band. So the idea is that you pick a band, so you pick something like the 1800 megahertz band, for example, and all 3 of these component carriers will come from the same frequency band, and they will be directly contiguous, or they will be directly adjacent to each other within that band. Now they don't have to be the same bandwidth, so we could have a 5, a 15, and a 20, and we could aggregate them together, to create an aggregated carrier of whatever the total bandwidth would be. It's possible as well that these radio channels, they don't have to be contiguous. So again, they could all come from the same band in this case, but there could in fact be a gap between them, yet it makes no difference as far as the aggregated service is concerned. Perhaps the most useful technique, and maybe the most complicated one to implement, within the radio systems itself, is so-called non-contiguous interband. So there is a suggestion now then that the channels, they don't even have to be contiguous to each other, but the bands themselves could be completely different. So we might find that we're using spectrum from the, should we say from, I don't know, the 2600 band, for example. We take a sort of 10 and a 15 megahertz radio frequency or radio channel from the 2600 band, and we aggregate that with a 20 megahertz channel from the 1800 megahertz band. Okay. Now, I know when I first started looking at this, quite a few years ago now, it just seemed so insanely complicated to build a radio that can actually transmit and receive simultaneously on 2 completely different frequency bands, aggregating different channel bandwidth together. It seemed kind of rather complicated. But of course, we've got people like Qualcomm out there who are doing a pretty amazing job in terms of building chipsets and so on to support not just multi-band radios, but multi-band radios that can do this carrier aggregation as well. And I think their latest chipset on the market is called it's an X16, and in fact it supports I think up to about release 9, I think it is. So you can combine, it's up to 4 different bands. I think I need to go back to the spec sheet and look at that. But already we've got kind of very, very close to gigabit per second radio modems being provided by chipset providers like Qualcomm. Now the other thing we need to kind of step back and think about a little bit here is, right, okay, if we can use different frequency bands, and if the channel bandwidths can all be different, then how many possible combinations are there of frequency band and frequency bandwidth? Well, what I recommend you do is you visit this website that you can see at the bottom here. There is an extremely good table there that shows you all of the possible currently defined band combinations. Now, I've just chosen one little snapshot of the table here, but you can see that we're actually combining here 4 different bands. Okay, so we've got band 1A, well, in fact, the 2100 band, the 1800 plus band, the 850, and in fact their TDD band at 2300. And they can be combined in various ways to provide a maximum aggregated bandwidth of something like 70 megahertz. Okay, but this is only possible in release 13 or release 13.2, or in devices that support release 13. So this is a very tiny snapshot. I mean, what you need to do is to visit this website and scroll through the table and just see how many different band combinations that there are. It's extremely complex. The other alternative, of course, is you need to go to 36 or technical specification 36101. Look at the release 13 version of that, and there's more information in there about that. So it's it's quite a complicated thing. Now, it seems extremely unlikely that there will be a chipset that will support all possible band combinations. It may be for a period of time very regional, because a lot of the bands that you see, the specific bands that you see in this table, might be different on a region by region basis. So a chipset which can support, one particular combination might work only in one part of the world, and when you go to a different part of the world, then maybe there would need to be a different chipset, or at least a different version of that chipset to work in that part of the world. So it's quite a complicated thing, but it's being resolved. As I say, there are a lot of clever people out there working on that specific problem. And in fact, when we stand back and look out the world and look to see how many LTE advanced networks that there are, well, there's quite a few. There's quite a few. I mean, this is the GSMA. I mean, if you're interested in a lot of statistics and tables, again, I would recommend that you visit the GSA website. There's a lot of good stuff in there. Now, this statistic here is from, you'll see at the bottom here, January 25th of 2016. And it says at the top there, 116 commercially launched LTE advanced systems in 57 different countries. Now, even since they published this slide, that information has changed. And I'll put that up in just a second or two. Right, but the other thing that we need to mention here is that not all LTE advanced systems are the same. Now, most network operators, when they announce to the world that they have launched a commercial LTE advanced system, it will almost certainly be a carrier aggregation version of that. What we also need, though, to support whatever version of carrier aggregation they have deployed, is we need the correct device category. Okay, so let me just throw up another an overlay on this slide. So here is a table showing the user equipment device categories from 0 through 16, okay, with the approximate downlink and uplink bit rate shown in this table. Now, the ones highlighted here in yellow are the, should we say, the currently available or most popular categories. So you can see here for device category 4, which supports 150 megabits per second in the downlink and maybe up to 51 megabits per second. This is predominantly through sort of 2x2 MIMO layering. There are 24 operators that support that particular device category, and there are many, many devices that can support that. So pretty much every device on the market. This is device type, by the way. It's not just the actual number of devices, but device type or category. So 2,500 devices, types of device in the market that can support that. Category 6, up to 300 megabits per second in the downlink, 51 in the uplink, and again we've got some MIMO layering in there as well. But there are 87 operators, 285 devices only for that. And then as you go through this table and you look at the higher and higher device capability, so 600 megabit per second now. In fact, there's only between 1 and 7 devices that can support this, and in fact there are only 2 operators in the world that are actually doing this. One of them, in fact, is, you can see in pink here, this would be a Telstra down there in Australia. They're one of the few operators that have got the sort of, should we say, the most complicated style of network. The biggest problem that people like Telstra will have by adopting this, should we say, the latest version of carrier aggregation and/or MIMO techniques, is that device availability is going to be fairly sparse. So sure, they've got the capability, but there are not that many devices in the market that they'll be able to kind of utilize their new and fancy network with. So let me just go back one page here. So you can see category 11 devices in pink here. In fact, the only, well, Australia, Tasmania, I think is the only one I can see there. But category 4, category 6, which are by far the most common, you'll see that, those parts of the world that have deployed it will be either category 4 or category 6. Canada, we've got Spain, and some of the sort of the northern European countries there have some category 9 devices in there. So it's growing, shall we say? I've just got a few sort of stats in here just to kind of wind this presentation up, but just a couple of examples. Deutsche Telekom in Germany have a carrier aggregation. They're using 20 megahertz from band 3 and 20 megahertz from band 7, okay, to achieve something like a 580 megabit per second peak speed, as they say, on a live LTE network, using a combination of carrier aggregation and 4x4 MIMO. So that's not bad, is it? Half a gig. I'd always be a little bit wary about the use of the term peak speed and live network. Your experience may vary, of course, depending on time of day and current network traffic and so on. But as a proof of concept, I mean, it's an impressive number nevertheless. But Turkey, you need to kind of go and look at Turkey, really, because I think all the operators in Turkey have launched well, I mean, 4.5G networks. I mean, proper LTE Advanced Pro has been deployed by all of the operators there. So I've just picked out on Turkcell here, using a band 1, band 3, band 20, band 1 combination for a total of 80 megahertz. But also using this 256 QAM and 4x4 MIMO, they've demonstrated something like 1.2 gigabits per second, and they also declare it as a commercial service, which is highly impressive. And it's a very, very rapid evolution to these extremely high speeds. I mean, I think LTE has only been around since 2009. I think it was when the first operators were deploying their network. So in a very short space of time, we've gone from supporting maybe 20, 30 megabits per second to now having networks declaring that they've got a gigabit per second available as a commercial service. Just the one other sort of caveat I would really put on these numbers. I mean, impressive that they are. Device availability. Okay, so sure, we might be able to demonstrate speeds like that, but can I walk into the Turkcell shop and buy a telephone that will allow me to do these speeds? Maybe not this year. Okay, maybe towards the end of the year, maybe early next year, there'll be such devices on the market. But I mean, I do recommend you go to the GSA and pull down some of their sheets, because there's a lot of really interesting information in there. And again, I've just pulled a couple of sort of snapshots out of one of their reports here, but it'll give you a breakdown of countries in the world, operators in those countries, and a little bit of information about what specific type of carrier aggregation they're supporting. So you can see here in the USA, AT&T commercial carrier aggregation, 110 megabits per second. So it's 2 times 15 megahertz from band 14 and band 17. Okay, so you get the idea of what you can read from those tables. Now, I mentioned on the previous page there was something like 116 operators investing in LTE Advanced. Well, in fact, now, as of this month, there are 163 operators investing in LTE Advanced in 72 countries. It doesn't seem possible yet to break that down into who is doing sort of, should we say, Release 8, Release 9 LTE Advanced versus Release 13 LTE Advanced. There's really not, I wouldn't say there's that many operators in the world that are actually doing LTE Advanced Pro or 4.5G as yet, but that number, of course, is going to increase significantly over the next 12 months or so. So, just as a final thought, this again is from the GSA, but we can say there are 717 operators in 190 countries getting involved in LTE. Most of those are sort of commercially live, I would suggest. 691 of them with some sort of pre-commitment trials taking place. 494 commercially launched, including, interestingly, 72 TDD versions in 43 countries. Right, but and I think there was a significant benchmark. Q4 2015, there are now more than 1 billion LTE subscribers globally, which is a lot. I mean, that is, well, there's about 7 or 8 billion connected people in the world, so it's a significant percentage now of the total number of mobile connections in the world. However, if we were to compare or contrast that with, say, the number of users on an HSPA Plus, well, I think there's about 4 billion, data users using HSPA Plus. So, for now at least, the majority of the data traffic being carried in the world is probably still being done over a 3.5G network or HSPA Plus network. But I think we're going to see that changing over the next sort of 12 months, 18 months or so. Device prices are dropping all the time, makes it more available to a larger market. People are constantly upgrading the devices on maybe a 1 year or 2 year cycle. So as things like carrier aggregation become more commonly deployed within the networks themselves, as we go into replacing our devices, then naturally, of course, we're going to get support for the latest chipsets in the latest devices, and we'll probably start being able to enjoy some of those higher speeds, 100 plus megabits per second, perhaps, at least in the next 12 months or so. So there's a lot going on there. So LTE Advanced is, I would say, well, perhaps I wouldn't describe it as completely wide scale at the moment, but activity is intensifying related to the launch of LTE Advanced and LTE Advanced-like services. I'll just come back to the Turkcell, the Turkish example here, because I mean, some of the operators in Turkey have gone. They've really gone from a 3G only environment to like straight into a 4.5G environment. So they've spent an awful long time kind of building out, designing, and planning their networks, and they've basically done a switch on at 4.5G. So they've gone from, say, a couple of tens of megabits per second, like to, bam, a gigabit per second. So through careful planning and deployment, I think it is possible to build out really high capacity networks. And of course, what they're doing is as a commercial organization, the operators in Turkey, they're making themselves much more attractive to potential third parties in terms of things like smart cities, the utility companies, all of those, advanced transportation systems. They're making themselves look much more attractive as far as the business is concerned for how they're going to generate revenue for the next generation, I suppose, and they're laying a very good platform out towards 5G as well. So right, I think we've probably pretty much come to the end of our time here. Now I'm just going to pull back in if I can find it. Right, I'm going to pull two things in. So I hope you enjoyed that. I know we don't really give you much time to listen in on these things, but if you've got any questions or comments, then there's a little chat box there. The one other thing I should also do right now, if I do this, it's probably going to make those things disappear. Just bear with me a second. Oh no, there we go. Right, let me just move some stuff around. Right, so if you've got any questions or comments, I'm more than happy to deal with those for the next 5 minutes or so. If you like what we do, of course, then visit our website. There's an email address there, training@telecomsacademy.com, and there is a telephone number there, and somebody's standing by waiting to take your calls right now. But yeah, thanks very much for your attendance. We do appreciate it. We do appreciate that. And I'm going to close my mic now, but thanks for attending, and we'll perhaps see you on a future training course. So for now, goodbye.